So my name is Brad Peters. I'm a geochemist, a postdoctoral scientist at the Carnegie Institution for Science. So my research looks for geochemical signatures of the very early Earth in modern rocks. In particular, I use lavas from oceanic hotspots like Hawaii, which are very young, most of them being erupted in the last maybe 50 to 100 years. And I look for geochemical and isotopic signatures of processes that happened 4 or 4.5 billion years ago, so in the first 1 to 10% of Earth's history. So that matters because we have very little material left over on Earth from so early in Earth's history, and so we have to use these young rocks, which tap material from very deep in the Earth, as sort of a proxy to understand what the very early Earth was like. And that sort of can satisfy a natural curiosity that we have about where we came from and the conditions under which the Earth formed. One of the isotopic systems that I work on is neodymium, and what we do is we take a sample and we purify it so that we have a very high concentration of neodymium, and then we take the neodymium from that sample and we put it on this filament here, and we dry it down so that the sample is then sort of solid on the top of that filament. And we put this filament in a mass spectrometer and we heat the filament up to very high temperatures such that the neodymium ionizes. And once it ionizes, it flies off of the filament and into the analytical side of the mass spectrometer. And that allows us to very precisely measure the isotope ratios of the different isotopes of neodymium. And depending on how that turns out, that might tell us that we have a very early Earth signature, or perhaps not. So you can find out more about this research at my presentation at the AGU meeting next week. I'm presenting on Monday morning in a volcanology session.